out what's going on with the space program. And they have, for whatever reason, they like me enough to allow me to rebroadcast this. So, make sure you go over there, subscribe to their YouTube channel. Maybe buy a One Hop shirt or something. Could we do an experiment and put this in just chatting?
Tank is larger, but still the size is, you know, the difference in sizes are like 4 or 5 rings, not more.
It doesn't seem like a lot, but a single ring can hold a staggering amount of propellant just by itself.
I mean,
it's 6
3 I
feet
could.
tall
We
and
could
9
switch it to
feet in
just
diameter,
chatting
so
if you want.
it's a lot.
I see Eric Berger just tweeted our stream, so he might be watching. Hi, Eric.
Eric, I am so sorry if you heard me burp. If you didn't, what? What are we talking about? Let's talk about Starship and the booster. We're getting even more full on the liquid oxygen tank here. That's what we want to see. This is leading me to hope that we are going to, in fact, get a 20-second static fire, which is just going to be so exciting.
All right.
Of some number of engines.
Got a little bit of a purge coming out of the OLM.
Engines.
Dude, it seems like it's been forever since I've covered any type of Starship stuff. They keep doing this stuff when I'm either away or on vacation. So, how many engines are firing? Should be a big one from the amount of propellant that I see in there.
What do we have in this fill if they keep going at the same rate?
Well, if you give me just 1 minute.
You should advertise your merch too.
You know what,
I have shirts.
Team-
Ismic,
Well,
thank you for the
hold on,
resub.
because-
25 months. What's up,
yeah,
dude?
because I said 1 minute, but it's actually 10 seconds. I found it. I'm
Possibly a
thinking
single engine's just to test the
sometime
autogenous
after
pressurization.
30
Yeah, okay, so
minutes.
they're doing an AP test. So what's autogenous pressurization and why does it matter? Well, on a rocket that flies up into space, you have fuel tanks, but you have a fuel and an oxidizer tank. Rockets bring the oxygen with them because there's no oxygen in space. So in order to create combustion, you need oxygen in some form, right? So they have a liquid oxygen tank and a liquid methane tank in the case of Starship. That's the LOX tank, the one that's really cold right now. The methane tank is up there. There, you see that kind of corrugated line right there. That's the CBH, the common bulkhead. So basically the bottom of the methane tank up here is the top of the LOX tank, right? So the methane tank is up here. So you have two liquids going in, right? Going into your rocket engines, and they are draining the tanks. Now, you don't want your tanks to implode, because once again, where the rocket's going, there's not anything to fill up the tanks after you drain the fuel, right? So, in order to feed the fuel at a there's another purge out there. In order to feed the fuel at the, same rate throughout the entirety of the rocket's ascent, the tank pressure needs to stay the same. If the tank pressure goes down, it's not going to feed the fuel into the rocket engines correctly. Now, I'll give you another example of something where the pressure needs to stay the same. The gas tank in your car, if you have a gasoline-powered car, pressure has to stay the same. So, as you drain gas, you need something else coming in, air in this case, because gasolines have vent lines. So, atmosphere goes in, liquid goes out. Now, once again, the rockets can't do that. There's no atmosphere to fill the tank up. So, if you didn't, you have to find a way to get something in there to replace the fuel as you drain it, or else the tank will crush itself, Mythbuster style. Remember when they imploded that? You guys remember the Mythbusters where they imploded that the tanker car? Yeah, that could happen. You don't want that to happen. So, rocket engines. So, let's take Falcon 9 for instance. A Falcon 9 has to fill the LOX of the RP1 tank with something. Whatever you fill that tank with is called an ullage propellant, right? So, ULLAGE, ullage. It's just a fun thing to say. Anyway, with tank ullage, they pump gases into the tank to make sure that it stays at the same pressure throughout the entirety of ascent so the fuel feeds into the engines correctly. Now, in Falcon 9, they use helium for ullage, for tank ullage. There's helium gas tanks inside of the fuel tanks on Falcon 9, and those feed into the tanks so the pressure stays the same inside of the tank the whole time during Falcon 9's ascent. Now, Starship needs to be, and Super Heavy need to be as simple as possible for rapid turnaround. So having to constantly fill and drain helium tanks, that is a lot of work. So what these things do is an autogenous pressurization system. So how does that work? Where are they getting the ullage gas from? Where are they getting it from? They get it from the Raptor engines. The Raptor engines have a tap-off there's a gaseous methane tap-off, and then there's a gaseous oxygen tap-off. And those lines that you see going up the side of the vehicle are pneumatic lines that take the gaseous methane tap-off and the gaseous oxygen tap-off, and the rocket engine actually generates gas on the side to be able to act as an ullage gas on the tanks. That's a lot simpler than trying to add a helium tank. And once again, Starship is trying to be as simple as possible. So they have an autogenous pressurization system. This isn't the first time somebody's done this. This is something that does work. The Space Shuttle external tank has an autogenous pressurization system for the same exact reason. Because you didn't want to make the external tank on the Space Shuttle complicated because you throw it away every time. You literally want the external tank on the shuttle to just be an empty tank. So the shuttle main engines actually had a hydrogen tap off and an oxygen tap off, and they used those to repressurize the tanks. And then when the space shuttle separated from the external tank, they would vent the gaseous oxygen and gaseous hydrogen, and it would cause the tank to tumble. So when it went through re-entry, it would completely burn up. Now, you don't need to do that with this. I don't think they want this thing to burn up in the atmosphere. They want to come back and catch it, obviously, right? So they needed to make it as simple as possible for kind of a similar reason to the external tank, but it needs to be simpler because they want to turn it around fast. They want to be able to use this thing over and over again. There's a deep press vent. Iron Spark, tier 2, 21 months. Thanks, man.
The most they have filled this tank, not, but the most that they have filled with.
So what we're seeing today is a test for the autogenous pressurization system. So I'm not sure how many engines this thing is going to fire. I don't know.
They have basically filled the whole tank up. With liquid oxygen, though, the most they have gone is a little bit under where the chines end, and that was it. And that was during the full stack testing. This is basically the most that they have filled with liquid oxygen so far.
It's funny, RJ, when I say that Super Heavy and Starship are a combination of a Saturn V and the shuttle.
Gotcha.
I mean, they use a lot of different parts, or a lot of different ideas, not parts. They're not using the same parts. They use a lot of ideas from a Saturn V and a lot of ideas from the shuttle and combine them into one.
SLS's power, 17 or 18 would have to be fired to surpass the 8 to 8.8 million pounds that SLS produces. But I also want to stop really quick and
is this going to be the 20s multi-engine test? I'm not sure.
Visual sign that we're entering the really, really business end where we want to really watch for an engine firing.
Ooh, I know this one.
Yeah, go for it.
Oh, go.
The FireX system starting up. We've seen that happen on previous firings now that they've had that system installed. And if you don't know what the FireX system is, it's not really a water deluge. It's more like water being sprayed by some high-pressure nitrogen. It's like that flexible hosing.
You want 33? I want a booster with 33 F1s. I mean, who doesn't? 1 to 3 engines is your guess. Whatever it is, so if it's a lower quantity of engines, guys, the burn is going to last longer because those engines have to generate gas, and the gas has to pressurize the tanks. It's going to take a second for the tanks to fully pressurize, into flight. Not fully pressurized into flight mode, but it's going to take a second for the engines to get spun up. So if it's less engines, I'm expecting a longer burn. If it's more engines, I'm expecting a shorter burn.
Alex, what? Chris, what?
Is that Bill speaking?
No.
This should be a 20-second firing. So if it's a 20-second firing, Thomas, it's not going to be a lot of engines.
For that as well.
I don't think if they're testing the AP system, and they fired like 20 engines, you might overstress the system. Oh.
Approximately 10 minutes.
We got the siren.
So the siren was at 1:25:30ish.
Fast forwarding.
1:25
So
p.m.
1:35 approximately for T0. Give or take a minute or two on either side.
They're thermally conditioning the engine.
Fantastic.
See that?
All right. Well, we have a siren.
See that condensation cloud? That's a good call, Phil. So see what's coming down right here? That little bit of condensation, cold air that's coming off the engines. It's coming from the area where the engines are. That's a good indication that they're going to fire, at least soon, or attempt to fire. And the reason is because one of the last things you do is get your engines to operating temperature. Because we're using fully cryogenic propellants here, not we're, they're using it, I'm not SpaceX. Because they're using fully cryogenic propellants here, long story short, that's a really cool way to say that the liquid methane and the liquid oxygen is really freaking cold. Because they're using really freaking cold propellants, they have to make sure that the engines get to operating temperature before you fire them. And believe it or not, a rocket engine's operating temperature, for all the turbine machinery and everything, for all the moving parts of the rocket engine, is really, really cold. It's just inside the combustion chamber, the throat, and the nozzle where stuff gets really, really hot. Everything else on the rocket engine, all the other equipment that you need to move the fuel into it, that is a really low operating temperature, despite being next to a rocket exhaust that is a really, really high temperature. So one of the last things you see here is them taking those propellants and kind of bleeding them into the engines. They start trickling the propellants into the engine and kind of flooding the thing, so to speak, to make sure that it's cold enough. And the end result of that is seeing some condensation come off of this, because as the engine gets cooled down and they remove the heat from the motor, I say remove the heat because it's relative here. As they do that, you basically, the engine being cold basically condenses the vapor in the atmosphere, and you see a little bit of condensation like this. It's the same idea as like if you have a cold drink in the middle of summer and you pull it out and it starts sweating. Same thing, only on a much bigger scale.
Bob, I had
How much weight do you think the LOX is adding? Good amount, dude.
Oh my gosh, yes.
You
When
remember
you
those?
do that in the 90s, oh my gosh, yes.
You remember that? Oh, that's perfect. That's
Yeah,
amazing.
it's
Thank
kind
you.
of crazy the thermal mediums that rocket engines operate at. Like the outside of the rocket engine, you'd freeze your hand to, but like less than a couple millimeters away on the inside of the rocket engine, you would have no hand left.
Like I said, all the pieces.
Crazy, right?
board. We're ready to go.
Do they also use
Let's see this
propellant
thing light up.
as a nozzle coolant? Yes.
Let's do this. Let's make
Discovery.
another
Butter,
Yeah.
87 months, Electron
notch in the
76.
belt on the way to an orbital test flight.
And
And it's important. Oh,
sorry, and
go ahead.
a quick question here from Alex, who's saying, is the large load related to autogenous pressurization testing? The answer to that is yes. On the oxygen side of the system, definitely. But you can also see the methane side getting frosty as well.
Yeah.
Which is more than we have seen in previous static fires, is it not, Alex?
Yeah,
Or
definitely.
Alex,
At least
not
for
Alex asking question.
yeah, definitely for static fire tests, this is the most that we have seen. We saw during the full stack test they loaded.
They run the
way
fuel
more
around
methane,
the.
but
So
obviously
they
those
run.
were for that kind of testing.
Empire, the fuel gets flowed through milled copper channels in the lining of the nozzle. SpaceX uses the liquid methane to do that. Now, why do they use the liquid methane to do that? Because it's colder. Straight up. Better temperature
Sometimes,
change.
We saw at least on the last.
Use the
static
colder
fire
propellant,
test
you can
that
run the
we did,
rocket engine
we
hotter,
were
you don't have to
actually
worry
went for
about
like
melting the
20,
nozzle.
25 minutes since the siren. So, be a little bit patient if we see some delay.
How
to
high off
that
the ground is the
static
milk
fire
stool?
From the
70, 80 feet?
The T-minus 10 minute siren. But yeah, we should be coming up in just a few minutes from that static fire test. And
Yeah,
as
just
I was
around
mentioning,
5. It's been 5 since the siren.
Yeah.
It'll be about 5 more, and like you said, it's a
Exactly.
kind of it's a guideline. We're not saying it's going to be exactly this or that, but it's a good guideline.
and
I'm not
one
watching
of the
both
indicators you mentioned the fire X system, but even before that, you can see a vent from the right side of.
Floating disk, 75 meters, or 75 feet is like a little over 20 meters.
Of around 40 seconds before the T0 time.
They do not need FAA
then the
approval
fire
for static
system
fires.
comes a little bit later, like a few
Adventum, you don't need FAA approval for anything that doesn't go higher than 1,000 feet. If it doesn't go 1,000 feet, the FAA does not care. That's unregulated airspace, because you can't regulate all the way to the ground. That's weird. So, if it's not flying, and doesn't go over 1,000 feet, or about 330 meters in the U.S., they don't care. But the static fire isn't flying. Hopefully it's not. Let's put it that way. Hopefully it doesn't fly today. We're just trying to see the engines fire.
And then the fire X system came on. So
because
if
it flies, we got a problem.
Yeah, that system coming on is kind of now the ultimate tell. Like if you remember static fires on pad B, whenever we see the water turn on at pad B, it's like, okay, here we go. It's kind of a similar deal. So
yeah, if this thing lifts off, we got a problem.
Right now, you can see it plain as day in the shot there on the left. We will see it start up. It's hard to miss. And if you haven't seen what that looks like yet, we do have the daily video that shows that.
An indicator to know that, like what Jack was saying, an indicator to know when this thing is going to start firing is that they have a fire suppression system around the outside here. That's what these things are. They're going to start shooting water on the pad this is a pad deluge. They're going to start shooting water everywhere. And then what you should see right before ignition is a huge puff of white smoke come out of the bottom of the engine. The reason why is because the puff of white smoke is basically because the rocket engine is already flooded. Remember how I said they put the propellants in the rocket engine to basically prime it? They flood the thing. And then when they start turning the fuel pumps on, or the turbo pumps in this case, some of that propellant does get immediately shot out of the rocket engine before they ignite it. So you should see a huge puff of white smoke coming out the bottom here right before ignition. But the pad deluge, so the water systems are a good giveaway when they're going to go.
Like, it's not a launch. I know it's not lifting off, but
there are launch vibes though, right?
But the butterflies, oh my gosh, yeah.
Yeah.
Will it have a launch termination system enabled in case it did take off?
Tank,
I don't think you have an FTS on here, Alleviate. I don't think the flight termination system is activated because you're really not intending it to fly. If you're not intending it to fly and it takes off, it usually means it exploded. So I'm pretty sure they don't, but who knows? Maybe they do.
The thing is, I said before they will probably not keep loading the liquid oxygen tank, but instead they kept loading it. It's the level of the frost is higher up right now, and I'm guessing it's closer to how they load Falcon 9, where the booster gets the liquid oxygen load.
Tell that to SN4. That took off. Yeah, but it took off, but it didn't take off in one piece.
Yeah. 9, that's how it goes. It might be T-1 minute for Starship or something like that, right?
Yeah, makes sense.
Who knows?
Certainly an extremely close to full LOX tank. Maybe an eighth of a tank left to go. I wonder if this is like max fill for using the autogenous pressurization, like rather than filling it up all the way. Part of the autogenous pressurization is having a little bit of head in there. Or Alex, were you earlier alluding to them only having the capacity to fill it up this much? Did I hear you right earlier, or was I mishearing you?
Well, it could be that. I was kind of guessing there. I actually said that I was guessing that max load could mean anything, right?
Yeah.
Could mean from regulatory, from tank farm capacity or something like that. So,
how many engines do you think will fire?
Potentially
low quantity
a minute
of engines
to go, or under a minute.
It should be. Elon said on Twitter that it's a 20-second burn. If it's a 20-second burn, testing autogenous pressurization, that's a relatively long duration burn for being on the pad. If it's 20 seconds, I'm expecting a low quantity of engines. So 3, 4, something like that. Not. It shouldn't be anything big. I don't think we're going to see a 15-engine static fire, but it could be wrong. I'm learning about Starship at the same rate that everybody else is. There's nothing I know that people don't know. In fact, I purposely try to avoid stuff like that. But
just
I'm going to
listening to just listening to the sounds of the booster. It really, times like this, like I know we're just doing a test, but it's useful to sort of inform your mind what this thing is going to look like on the pad when there's a Starship on top and it's getting ready to launch. It's going to look not far off this, and that just makes what we're seeing right now that much more exciting. It's an active, alive, breathing rocket ready to light its engines. How cool is that?
That we're seeing from the top of the liquid oxygen tank very reminiscent to just pressure relief vents and pressure nominalization event vents that you would see in other rockets. So fascinating to see and watch this part of the process. I'm sure Adrian is also recording this down to the millisecond for the spreadsheets and everything.
Gotta love it. More data, more better. 130.
More data, more better. Than not
136 now. Like we always say, the siren is more of a guide. It's not ironclad.
Guys, I'm gonna shut up here so we can
hear
the audio. I'm just letting them talk.
Seemingly in the flow here and getting very close.
That logs load is almost complete now.
You're right.
It's almost there already. Just a tiny bit, maybe less than 10%.
This is fantastic.
Yeah, this might get loud, Sun Temple. Yeah, headphone users.
Exactly the test we were hoping to see today. Let's get some engines lit and get some data gathered and get even closer to an orbital test flight with this vehicle for the first time.
Very much agree with that sentiment there, Jack.
137 now.
I wonder if the FireX system, if they decide for a spin prime instead of a static fire, whether that would be also different. We saw on the previous testing that they did the FireX with just nitrogen for a spin prime, but the full system for the static fire test. So that might be an sort of a spoiler alert. If we see the FireX and only the nitrogen side active, that probably means it's gonna be spin prime. But you know, he's hoping for water. Hope for water, and you get the fire.
They gave out an overpressure notice. They did the siren.
Yeah.
All signs are pointing not to a spin prime, but to a static fire.
Be stored at
that's what we see.
Higher density, dude. So yeah,
you know, it's also
use
really
it as a counterweight to weigh down the engines.
Look at how frosty the liquid oxygen tank is. Imagining the
it's not a spin prime
methane tank on top of that, also frosty, and a frosty ship on top of the booster is just becoming more.
It's so amazing.
Real. I know. It's becoming more and more exciting watching SpaceX march through the maturity of this new system.
Yep. As cool as I don't mean that as a pun. As neat as the vehicle looks, all shiny and chrome, something about it, white and silver, is really special. Maybe it's that I know it's full of fuel. It's full of the stuff that makes it do the thing that we want it to do.
Indeed, it's full of the good drink.
I ignored it.
Yeah, it's got its go juice.
Go juice. There we go.
Well, coming up on 139, just waiting for. Maybe they're just waiting to get the LOX tank topped off. I mean, we're real close now. The frost is way up there.
Yeah, it could be any minute.
You might be right there, Jack. Yeah, that might be like part of the topping sequences that we were seeing there.
Nice, Adino sign.
LOX topping on the booster, LOX topping on my bagel. Thanks again, Trevor.
Nice.
It's just a LOX-filled morning for you, isn't it, Jack?
Which makes it a very good morning. Which makes it a very good morning. I mean, any morning where we're going to do some testing of spaceflight hardware.
LOX load is complete.
Alrighty.
All event has come up, so that means LOX load is complete.
Thank you for that.
All right, Alex. What does that? Do we look for a change in that vent? Does it pulse? What does it do?
Well, we're waiting for the fire right now. The FireX. The
Gotcha.
OLM vent, the one on the side.
What you're seeing there.
Then the FireX system.
What you're seeing right here, dudes, is basically the fuel lines going to the booster. That's the LOX fuel line going to the booster. Right before you fire your engines, you want to get all the fuel out of the fueling lines, right? Because if something does go wrong, you don't need to give whatever explosion happens a path back to your big fuel tank that's has a lot more LOX in it, that's off to the side of the pad. So what they do, most rockets do this, they purge out the lines. It's a nitrogen purge to fill the fuel lines with inert gas to make sure that if something does go wrong, it doesn't break the pad too much. You don't need the pad blowing up from the inside out. So what they're doing is they're getting the LOX out of there. And the result is a lot of gas gets spewed out of the OLM.
Load more methane on there if they're just getting things temperature-wise in the right area they want them, or Dare I
Any
hate to say
minute
it,
now.
maybe they're in a hold? I don't know. But it could be any second now.
Yeah, the methane gets put through a scavenger, Balxy, correct.
Just waiting for that fire X system to start up.
As we said, the butterflies.
Yeah, they're real. They are real. It's been like 16 minutes since the siren. Somewhere in there. We are 6 minutes past when we expected 10 minutes from the siren to be. So.
Alleviate tough question. Let's watch a static fire. I can answer that
exciting.
one later. Thank you for your stream. No problem, Zyvox.
Oh, that's the vent.
Okay.
Okay, so FireX next.
Any second now.
They're putting liquid oxygen. They're moving liquid oxygen out with gas. Toulouse.
Here we go.
There we go.
All right.
Oh boy.
All right, let's listen into the sound of these raptors.
Holy moly.
Short. Burn was short.
Wow.
Wow.
The burn was short. That was an abort.
Booster 7 in
It was 12 seconds.
Quite an engine display of power there. And
Beast
there
mode,
is the
dude.
booster in question. Standing tall and proud on the orbital launch mount. Everything clearing out of the way of the cameras there.
That was awesome.
Oh, wow. That was a pretty good duration hold down again, wasn't it?
I've been talking. I was
I saw a
muted that
fire
entire
in the
time.
middle of the
I'm a
rocket
failure.
near one of the vents.
Yeah, that looked great.
There's
That looked
those
absolutely
things
Actually,
great.
trying to look
make
at
fire
the
that come out the
duration. It started at 1:42, 16, 17. There we go. 1:42:17 p.m. and seemed to shut down around 1:42:30 p.m. So that was
in the middle.
13
Yeah,
seconds.
I know. In the middle, there's these things, Jackal, called
healthy,
rocket
long
engines
fire.
that make fire.
Very nice. The OLM.
I'll have to go
looks
back
like
and
it
look
got
and see.
some charring on it, but
Yeah,
doesn't look all that bad.
a little bit of a
It's in
grass
one piece
fire
at
going.
least, which is
Yes.
it's a positive thing for me at least. I see maybe some fumes, smoke from the grass on the bottom of the right view.
Yeah, it's fine.
At the top of the LOX
That's
tank.
nominal. Excellent stuff. Well, hopefully SpaceX got the data they wanted.
All right.
Now we wait to see what happens next. Here
Let's
we
go back and
go.
look.
There we go.
Oh boy.
This is a replay here.
All right, let's listen into the sound of these raptors.
I don't think there was fire up there, Jackal. You probably saw a reflection. There's no methane up there for it to. There's no methane up there for anything to combust. Yeah, it aborted.
Holy moly.
That was an abort.
Wow.
They overpressed the LOX tank. You guys are right. The LOX pulses went off like crazy. Beast mode, though. You see that thing? What a freaking monster. Here's a reflection on the vapor. Gotcha, man. Yep. Let's see it again. Dude. Oh, man. That thing's crazy. So it sounds like shutdown was fine. So just a little word on this here. That tower is 500 feet tall. So that's about 150 meters. the flames, the clouds got to 150 meters pretty quick, didn't they? it's pretty nuts,
Holy
dude.
moly.
Wow. I'd cut down the duration before
Now
the test.
we're back over to live here.
Raptors shut down during the test
go at
for
throttle.
whatever reason. We don't know, but
Beast,
we
isn't
can
it?
wait
Isn't
for
that thing cool?
Fox to tweet it out.
I saw two, and there was a
Fair enough.
sequenced ignition, Thomas,
All right,
for
well,
sure,
with that,
but I don't
I'm
know
going
what the
to
quantities
jump
of
out
engines
here
were. It's really
and
hard to
get a
say.
video of this turned around as fast as I can.
7 that
thank
was
you so
only
much, everybody,
3.
for watching and listening to us. We're going to keep hanging out. I am going
How do you know,
to
if you don't mind me asking?
throw it to our good buddy Sawyer, who was going to take my place and hang out with you guys as you wait to see what happens next. I'll see you guys in a minute.
Yeah, no.
All right. Thank you, Jack, and thank you for getting those videos turned around. And hi, everyone. I am Sawyer Rosenstein, jumping in here, helping out with comms after what looked like a fantastic static fire test. As we
I know that guy.
wait to see
Sawyer's
what
pretty
comes next. So I don't know about you guys, but the sound from that one really just blew me away watching it
Hey, Wilson.
along with the rest of chat there. I'm sure you guys felt the same way.
Oh my gosh, it really was. I mean, like we were mentioning it right before the engine
That's NASA,
fired,
man, yeah.
Sawyer, and like it's not a launch. It wasn't supposed to leave the ground. It was supposed to do what it did for all intents and purposes visually.
I don't know.
And you
Michael,
still
that's
felt those launch jitters.
methane
and
first on
everything.
Starship. Yes.
Oh, absolutely. Yeah, you get that excitement bubbling up of like, oh, is it going to go? Isn't it? And then it
Sawyer's
doesn't
good
disappoint.
people, Fistus.
It doesn't, and I think a lot of that for me
One of the
truly
nicest
comes
dudes in
down
the
to,
spaceflight
it's not just
journalism,
that the design and what it could
kinda
do overall,
community.
could be quite revolutionary in many regards. It's
Methane
how
up top,
important it is to
locks
the
on
future
the-
plans
on the
of
bottom.
lunar settlement and Mars thereafter.
Oh,
So
no.
that's a large part of it. Exactly. Moon.
Yeah, again, the fact that right now we have Orion orbiting around the moon, and now we have this next static fire of what will eventually launch the lunar lander. This is the hype is real.
Pretty good time, dude.
Now, I don't know
Really?
about you guys, but I just the hype from all this has gotten me excited. I realize I also don't have any Starship merch. I think I need to change that. And
Well, we were all just chanting moon, moon, moon as well.
Yeah, no
oh
problem.
yeah,
a little-
almost like there would be a shirt there in our shop at shop.nasaspaceflight.com. Or better yet, if you really want something Christmassy and Starbasey, we have these fantastic sweatshirts that also come in t-shirts for those of you that are in the cooler climates like myself. And it's great. It's got a lot of stuff here from Starbase and a bunch of Easter eggs that are really fun to look at if you take a really close look at the design. So for all of the Starbase fans out there wanting a little bit more Starbase love this holiday season, there you go. All right. While we're
Say
waiting,
that,
go ahead.
I was about to say, because that support really feels throughout the whole NSF. I just was mentioning in the back channel before that those cams are still alive. Long gone are the times where they did a static fire test and some cam went down or something. We spend that money from your support that goes into strengthening all of this and having better coverage overall. So yeah, it doesn't go to nothing. It just goes to better coverage.
Yes, your contributions help us pay for the robot camera food that we feed them to keep them running and
Chris-
happy.
Chris
The
mentioning
robot
horse cam.
food, yes, the photons from the sun. Yes.
Yes.
Yeah.
Oh, I just nicknamed it Robo Food.
Well, I mean, to be fair, every once in a while, DOS does go out and scratch their little chins and call them good robots and has a talk with them all and, gives them a pep talk.
You can do it, little buddy. Come on, stay online for us.
Exactly.
Stay frosty, my friends. Yeah,
Stay
during the
frosty.
Static Fire, we have a whole bunch
Nice.
of people gifting
Yeah.
memberships, which is another way that really helps support us. So, thank you.
So, fellas, all right, just NSF being cheeky aside here, I don't see any vent down here. So, if they were done with a test, they would have vented down the tank by now. You would have seen a really, really big vent come out of that thing right there. And there's one adjacent to it right there. There's kind of two vents that kind of point down like this. That, and it's also kind of an interesting thing to note here that they did not. The idea was to, at least per the chief engineer, Elon, was to fire for 20 seconds, and that was, I counted 12. It was about a 12-second burn. So they didn't get full duration with what the chief engineer said. So that coupled with no vent down here means we might see another one here in a second. They also filled the entire LOX tank. Yeah. Well, that was also said like 2 weeks ago, so plans may have shifted a bit. It's possible. But Thomas, don't you think we would have seen a vent down here from now? They would have alleviated the ullage pressure out of the tank. It brought it down from flight pressure. It doesn't seem to have done that here. How many engines? I'm not sure, Monica. There was a lot of fire coming from the bottom. Does that help? Like, maybe that helps? I don't know. It was definitely a sequenced ignition, guys. So there were two sets of engines, and they fired one set and then fired the other. I don't know if one set of engines was just one engine or another set of engine was just two. The fire suppression system that they have on here and the pad deluge, like this kind of pad deluge system thing is makes it kind of hard to see how many ignitions there were. I did count two sets of sequenced ignitions. So you had the initial blast from the first engines firing, and then after those engines came online, they fired a second set of engines. You can tell because if we go back and look at the replay here, if we go back and look at the replay, you can distinctively see two flashes coming from the, you distinctively see two flashes coming from here. Watch. You'll see one. Sequenced ignition. They called offsides and then the half ended 1-0. Oof. All right, watch. So let's watch this in kind of slow-mo here. All right, here we go. So there was one. That's one engine turning on. Or one set of engines turning on. And then, see, there's the second one. Oh, it looks like I saw a third one there. Okay, one flash. That's one engine on. Second flash, another engine. Third flash, another engine. There were 3 sets. There wasn't 2, there was 3. How's SpaceX not using a flame trench? It turns out if you put the rocket high enough off the ground, you don't need to worry about it as much, I suppose. Now, Novaraptor, I still think that that's not high enough for how much thrust this thing produces, but yeah, it was a sequence ignition. Now, why would you do a sequence ignition? I'm going to get us back up to live here. Why would you do sequenced ignition? So, okay, so first of all, let's break that down a little bit. What does sequenced ignition mean? So sequenced ignition is basically when you stagger the firing on your rocket engine. So most rockets have multiple engines in the first stage. Sometimes, I mean, even rockets that don't, like a rocket, like take Delta IV Heavy. Delta IV Heavy has a single engine in the first stage, but if you have Delta IV Heavy, they actually sequence the 3 cores. Now, there's a couple of reasons why you do that. In the case of Delta IV Heavy, they sequence the 3 RS-68As. They fire 1, and then they fire 2. The reason why they sequence it in the case of Delta IV is to mitigate that huge flame that comes out of a Delta IV because of an open cycle hydrolox engine. Basically, too much hydrogen gas can get built up and the fireball can get too big. So they fire one engine and have the vacuum from that one engine firing pull the flames down, and then fire the other engines and pull all the flames down into the flame trench. Because rockets, because they accelerate gas so ridiculously fast, they actually create a vacuum effect. And that vacuum effect can happen and pull stuff down into the flame trench. So, like with Delta IV, they sequence the Delta IV Heavy to make sure that they don't have a big fireball. Now, you don't necessarily need to do that with something like Super Heavy. The Raptors will get rid of any unburnt methane very quickly, but full flow stage combustion gives you really, really high efficiency, coupled with a really, really high amount of thrust. So there's not much residual unburnt propellants coming out of the bottom of this thing. Don't get me wrong, there still is, because it's methane. There's still a little bit of unburnt carbon coming out of the bottom. But Super Heavy would sequence an ignition, long story short, for load on the vehicle. Firing all your rocket engines all at once can put a shock compression load on the vehicle. Now, what does that mean? You fire all the engines at once, basically you crumple it like a soda can. Because you're introducing, because rocket engines, when they fire, they have an overpressure event. And that overpressure event basically gives you a little bit of a bump. And what shock loading is in engineering dynamics is introducing a load very, very quickly. So, I'll give you an example of shock shear load. A wrecking ball. You know, on a crane that has a wrecking ball attached to it. You have your wall, you have the wrecking ball. Ball hits wall, introduces a lot of force really, really quickly, right, to that wall and shears the wall off or just knocks it over. That is shock shear load. Because the wall stands upright, so shearing would be perpendicular to it. That's shock shear load. Literally that, but pushing up on the bottom of the vehicle. If you try to fire all your rocket engines all at once, it would be like hitting the bottom of the thing with a wrecking ball. You really don't want to do that. That causes explosions. Most things that don't make a rocket work correctly usually result in an explosion in multiple directions. So what SpaceX does with Super Heavy is they fire some of the engines to get that load up. They fire some more of the engines to progressively load it up again, and then they fire another set of engines to make sure they kind of introduce a staggered load, so those bumps when the rocket engines turn on aren't enough to crumple the bottom of the vehicle. If you fired all 33 of them all at once, yeah, it would break it. It would break it. So how much of a stagger are we talking about here? So with that thing, we saw 3 fires within a half second. Basically, at 2.25 speed, I was scrubbing through pretty fast. We saw 3 firings within a half of a second. Usually it's down to the millisecond. You don't need to stagger it like by a second, like one engine. No, it's like 1 engine, 2 engine, 3 engine. About that fast. It doesn't need to be staggered too much. But that in itself is what sequenced ignition is, when you stagger it around. So on like Falcon 9, for instance. And Falcon 9 has a sequenced ignition. And the reason why Falcon 9 has a sequenced ignition is basically to do the same thing, not shock load the octaweb, the bottom of the booster. So what they do is they go around the horn. There's 8 engines on the outside, 1 in the center. They go 1, 2, 3, 4, 5, 6, 7, 8, and then fire the engine in the center 9. But they're staggering the ignition by a couple of milliseconds. It doesn't need to be too far apart. The space shuttle, for instance, does the same exact thing. The 3 main engines on the space shuttle, they fire 1, 2, and 3. But the ignition is not too far apart. But once again, it's for load. Also, firing, it's primary for load, but on ULA, it's primarily for has-gas concerns. But there are other reasons why you wouldn't want to do that. You don't want to. You can introduce a resonant vibration by firing all the engines all at once, and the vibrations can compound on top of each other. So if you have an engine that's rumbling like crazy and you fire off like 5 of them at the same time, they don't just kind of cancel each other out. They can combine, and the amplitude of the resonant vibration frequency can get higher. And that can break stuff. Rocket engines are shaking like crazy. They're shaking all over the place. And too much shaking will break it. It will break it. So the other reason why you do a staggered ignition is to get the vibrations from the engines to basically cancel each other out. And that can help mitigate it. That'll introduce a non-compounding effect of detractory event. That's not a word. The vibrations will get less if you sequence the ignition. That's what I'm trying to tell you. We'll be watching Neuralink tomorrow. What time? Yeah, you could implode a propellant line, Aqualux. Yeah, that's another thing. But yeah, I saw 3 sets of staggered ignition there. So I know it's at least 3 engines from Super Heavy from that first static fire. And once again, I haven't seen a vent down here. So they might be good to go for another one here, depending on what's going on. So yeah, that's why I'm watching for sequence ignition, because you can get a little bit of an indication as to what they're testing. Like, I know that they fired at least 3. I saw at least 3 engines, but the camera might not be a high enough shutter speed to pick up the millisecond sequencing between engines. So I saw at least 3. It could have been 3. It could have been 6. It could have been 9. It could have been 12. Who knows?
The excitement more of, it should be happening, but it's just a matter of when.
Yeah.
I still find that exciting.
There is also, correct me if I'm wrong here, Alex, but I know you probably also have it in your mind. There was one hop that demonstrated a hold point after where we would see the siren. So there is a hold point where they could hold after they would usually ring the siren. If I remember correctly.
Hey, Sleepy.
Yeah, usually the siren, while the notice says 10 minutes before the test, sometimes that siren can be a little bit more than 10 minutes, either because they hold or because they take a little bit longer than they expected or something like that. It's usually not an exact 10-minute siren.
Exactly. Yeah, and I believe we'll see where we go from in future testing. I know all of you guys updating your spreadsheets on the timelines and everything. It doesn't help you, but again, it's always a good indication. The best one being we saw the FireX system fire up and get prepared.
That's always so cool. I love the fact that we have this low, like very close to ignition indicator. It really helps you to just enjoy these last few seconds before ignition.
Yeah,
so
I'm kind of with you on that one.
I really like that. I
still think that we might be in line for a test by the end of the year. Because of SpaceX's rapid prototyping and testing, I firmly believe it really depends on how well these tests go. If they get the data that they need to prove their analytical models for what Super Heavy and Starship are going to do, the sooner that data gets obtained, so basically the better these tests go, the sooner we're going to see a flight. Because you're messing with pretty much one of the most complicated rocket boosters ever devised here. This is a complicated system. There's 33 engines. There's 33 engines. The stage is reusable. It needs to be caught by a catch tower. Now, don't get me wrong. I don't think SpaceX is even considering trying to catch this on the first try. They'll probably expend it. At least that's what I've heard from their orbital flight test, that this thing is just going to get wasted, which kind of sucks, but it is what it is. It's the most complicated first stage, even in an expendable form. There's no one has made a first stage that's more complicated than this thing. Even the N1, it's more complicated than that. Yeah, there's more engines, and not only is there more engines, but the type of engine that you're dealing with here is way more complicated. So if, let's say the N1 engines, right? The N1 engines are akin to a 4-cylinder car, right? There's 4 pistons. It's it's an engine. It's complicated, right? These Raptor engines are like a V12. There's more moving parts. There's way more moving parts, and it's way more complicated than than an engine with 4 pistons, right? Your crankshaft is ridiculous for what it's worth. You have 12 pistons as opposed to 4, right? There's more moving parts, but a V12 can make way more power than a 4-banger, right? Of equal displacement, you can make more power. But that's for other reasons. Those Raptor engines are like V12s. They're like a lot of V12s comparatively to like the N1. So the N1 was using relatively simple engines compared to what Raptor is. Now, for the nerds, an N1 rocket was using NK-15s and NK-33s. NK-15s are an oxygen-rich stage combustion cycle engine. So basically, to get better performance and alleviate, listen up, because I'm kind of answering your question. Basically, you have a couple of different types of fuel delivery mechanisms for rocket engines. You have something like a gas generator open cycle, like what a Merlin engine is, or what an F1 engine is on a Saturn V. Those are very simple engines. You have a gas generator. The gas generator makes shaft horsepower. The shaft horsepower turns 2 fluid impellers, and that moves propellant into the rocket engine, and boom, comes out the bottom. That's about as simple as you can get. The only way you can get simpler than that is like a pressure-fed system, where you literally just use the pressure of the tanks to force the propellants in to the rocket engine. But that, like, in terms of like making a first stage engine, you don't really generally have pressure-fed systems like that. That's really more for like on-orbit stuff, because it's simpler, and they don't really make as much power. Neuralink is tomorrow. Also listening. Got it. So with something like just a regular gas generator open cycle engine, you can make a good amount of power, but you're leaving some efficiency on the table. They're not very efficient engines. So like Merlin 1Ds are not very efficient engines for a Carolox engine. They're pretty good. They're pretty good for what they are, but they're not entirely efficient. One, because the Merlin needs to run super fuel rich to keep the engine cool. An engine that has a simple actuation system, and you don't like have the propellants moving through the nozzle to keep it cool, needs to find another way to keep it cool. How a Merlin engine stays really cool is that they basically flood the thing with kerosene, which is why Falcon 9s, when they come back, have a big sooty cloud on top of them, because the engines run fuel rich for cooling purposes. And they spray out a lot of extra fuel. Now, the same thing is for the gas generator on a Merlin. It runs fuel rich as well, which is why you have that big soot cloud coming out of the side if you watch like a Merlin 1D firing. Now, that's the simplest way you can do it for like any orbital class engine. That's about as simple. Gas generator open cycle is very, very simple. Now, you get into something like the N1. The N1 is kind of complicated. The problem with a gas generator engine is that, once again, you're not very efficient, because you're taking liquids, and you need we need 2 liquids, liquid oxygen and liquid kerosene. You need oxygen and kerosene, liquid oxygen and kerosene to atomize together. They need to combine, and then you need to blow it up. Unless you design a really, really nice injector plate, a really, 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 really good way to get the fuel and oxidizer to combine with each other through your injector plate, you're going to leave some performance and some efficiency on the table, right? Once again, Falcon 9 flying through its own exhaust covers it in unburnt carbon, because the Merlin engines aren't very efficient. They're not the most efficient. They're spewing unburnt fuel and unburnt oxidizer out the bottom of the engine. Now, enter something like the N1. The NK-15s on the N1 are using an oxygen-rich stage combustion. So what does that mean? So you have kerosene and you have liquid oxygen, and they both get delivered into the engine. But what an oxygen-rich motor does is eliminate that problem that I was talking about, of all that extra fuel getting shot out the bottom of the engine. How do they do that? Well, they get an NK-15 engine would give you better atomization. What is atomization? Atomization just speak in plain English terms, are basically how efficient you can get your fuel molecules and your oxygen molecules to combine and hug each other before you blow them up. That's before they chemically deflagrate, if you really want to use the technical term. Before they explode. It'll go right to your thighs, and then you'll blow up. So, what an oxygen-rich stage combustion does is before you still have a gas generator, just like you do before, right? And you're taking the kerosene is getting shot into the combustion chamber of the rocket. Same thing. It's very similar. But the liquid oxygen coming in does two things. So, when the liquid oxygen first comes into an engine like an NK-15, what they do is they put it through the nozzle to keep the nozzle cool, because you can't run fuel rich with an oxygen rich stage combustion. Okay? Oxygen rich, fuel rich. Pick one. But there's an asterisk next to that. I'll get more into that in a second. So they run the liquid oxygen through the engine for cooling. And then that liquid oxygen gets heated up, and it comes out and it goes into a preburner. That heated oxygen gets hit with a little bit of kerosene, just enough to heat it up even more and get the oxygen to really spread out. Because introducing a little bit of combustion into it is going to heat your propellants up. I mean, some of it is going to combust and explode, but it's going to heat up your propellants. And mainly it's going to heat up your oxidizer. And it's going to heat the liquid oxygen so much that it'll turn to a gas. And that gas is what that gaseous oxidizer rich mixture. So there's not a lot of fuel, there's a lot of oxidizer, and it's in gas form now because you heated it up. That goes into the engine. When you have gaseous oxygen hitting liquid fuel, or kerosene in this particular case, you get way better atomization. So all of that kerosene combines with all of that oxidizer, and you get a very efficient, very powerful burn. Because kerosene is very reactive. It releases a lot of energy really quick. Hydrocarbons, man, that's what they do. The energy density in a molecule, like a strain of hydrocarbon, is very, very high comparatively to like other things, right? So you get a very energetic reaction, and thanks to atomizing your oxygen, you get a really efficient reaction. Best of both worlds, right? Pretty good. But you're still at the mercy of kerosene, which, once again, very energetic, but not very efficient. This does improve your efficiency a lot. And that's what they were trying to do with the N1. They were trying to develop an engine that was powerful enough and efficient enough for a first stage. Turns out putting like 29 of them together really caused some problems. Need sound. Round 2.
We saw that in previous times where they
Okie
did the main test of the day, and then they were testing again this fire system. But it's nice, it's getting...
Long story short, those are way more complicated. They atomize fuel and oxidizer.
At this point, it's like running for a minute or so that's way longer than in any test, right? So we are probably safe here.
Yes. It seems like also the vehicle is pretty much being safed too, so at this point it's more the FireX system. But it's a great demonstration where you can really see just how this system works. I mean, obviously we got a good view of it before this most recent static fire, but talk about a great indication of how this system is going to use that nitrogen gas and water as part of its suppression.
If they fire the engines now, it will be the fire surprise system.
Oh wow!
I guess
it's condensation because the propellants are cold.
It's not getting better, and it stopped.
There it goes.
It didn't like that joke.
Oh my gosh! So yeah, now we know. We know how to stop the FireX system. Alex, you've got the magic words.
Surprise?
Surprise FireX!
I'll keep the audio on a little bit in the background. Hey, another oxygen-rich stage combustion cycle is a jet afterburner. Yeah, reheat is kind of like that. The interesting thing, Aqualux, is that on a stage combustion cycle engine, you have pre-burners, not afterburners. Yeah, pre-burners. What I like to describe a stage combustion cycle engine as is basically a jet engine shooting its exhaust into a rocket engine. That's what a stage combustion cycle does. Because like I said, the more you can get your liquid fuel and your oxidizer to spread out and then meet each other, the better atomization you're going to get, the better they're going to hug each other. And if they hug each other better, you're going to get a better explosion. That's what Raptors do. Now, like I said, that N1 engine, the NK-15, right? The NK-15 uses oxygen rich, so it atomizes oxidizer. And that gets you a very efficient burn with Keralox. Now, problem with kerosene is that hydrocarbons release a lot of energy, but they're very, very inefficient. Ask anybody that owns a gasoline car, you know what I'm talking about. The electric car people are going, ha, 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 ha. Yeah, well, there's downsides to what you do too, so shut up. Anyway, no, sorry, I digress. So, now what's the opposite end of the NK-15? The opposite of the NK-15 is the Space Shuttle main engine, the RS-25 or SSME. That is a fuel-rich stage combustion cycle. So what does that do? Well, the Space Shuttle engines are using liquid hydrogen. Liquid hydrogen is way colder than liquid oxygen. So what the shuttle engine does is it takes the hydrogen and flows the hydrogen through the nozzle, right? And heats up the hydrogen and then puts it through a pre-burner, right? Introduces a little bit of oxidizer into it, and they get that hydrogen to spread out like crazy. And that super fuel rich gaseous hydrogen mixture is what finds its way into the shuttle's combustion chamber, the shuttle engine's combustion chamber, with some liquid oxygen, and boom, you get a very, 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 very high energetic reaction. And because you're using hydrogen, it is insanely efficient. Space Shuttle main engines, this is for the nerds now. Space Shuttle main engines can produce 2,400 kilonewtons of thrust at 450 seconds specific impulse. That is absurd. That those numbers should not exist. Like, don't get me wrong, they do. Like the shuttle engine, we saw some shuttle engines, X-shuttle engines go off the other day. It was pretty damn cool. And because hydrogen is so efficient, it burns so efficiently, and because you atomized it and then combined it with liquid oxygen, you get all the benefits of the energy that hydrogen releases and all the efficiency benefits. You have a really efficient, very high thrust engine, which is, like, you want to know how efficient it is? The flames coming out of the Space Shuttle main engine are literally clear. You could see right through the exhaust plume of a space shuttle. Space Shuttle main engine firing. You can see right through it. That's how efficient it is. It's burning most of what you put into it. Now, you don't get me wrong, no chemical deflagration is 100% perfect. You're going to get exhaust. The exhaust gases that come out of a shuttle engine are H2 and O2. And then, well, H2 and actually just gaseous oxygen, if you really want to know. And the leftovers from a space shuttle engine's exhaust end up coming out of the rocket engine once they cool down, and you get H2O. Water vapor is what comes out of the bottom of the shuttle engine. It's the other reason why it's so clear. Now, that's fuel rich. So fuel rich stage combustion gives you better atomization with your fuel, but it favors hydrogen. Oxygen rich stage combustion cycle gets you better atomization with your oxidizer. And that gives you a way more energetic reaction. You get a bigger boom coming out of the bottom of the nozzle. But it's not, and it's a little bit efficient, but you're still hampered by how, like, the molecular structure, whatever fuel you're using.
Discovery,
right?
go and throttle up.
Hydrocarbons give you a really nice energetic explosion, but it's not very efficient. You have carbon emissions. Hydrogen gets you a very, very efficient explosion. And if you use a fuel-rich stage combustion, you get the thrust that you need. Right? So just as an example, for like a shuttle engine producing 2,400 kilonewtons of thrust at 450 second specific impulse, that's like having an engine that generates 1,000 horsepower. 1,000 horsepower at like 120 miles to the gallon. It's extremely efficient. So that's kind of this side. You have the performance side here. Now, what's the downside of this? There should be no downside, right? Well, the downside is using liquid hydrogen is kind of difficult. So right in the center of these two is Raptor. Raptor's right in the center. Raptor is a full flow stage combustion cycle, meaning that Raptor has two sets of pre-burners And one preburner is there to atomize oxygen, and the other one is there to atomize your liquid fuel. Now, what's your liquid fuel? Your liquid fuel on a Raptor engine is not kerosene, but it's not hydrogen either. It's literally in the center. It's liquid methane. Liquid methane is CH4, so it's a carbon atom with 4 hydrogen attached to it. It is halfway between hydrogen and kerosene. So, with Raptor atomizing oxygen and atomizing methane, and then combining those things and then putting it into the rocket engine, you get the best of the NK-15, a very, 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 very energetic burn, and you get the best of the space shuttle main engine. You get the efficiency combined into one. The problem with that is you're going to get an extremely, extremely high pressure explosion inside of Raptor. So you really have to make sure that that Raptor combustion chamber is very, very strong. Raptor engines, per testing at McGregor, per what we've heard from Elon, make 300 bar chamber pressure inside of the combustion chamber. 300 times 1 atmosphere pressure. So the pressure that you're feeling right now, 300 times that. That's, let's see. That's 3,000 kilopascal, or 3 MPa chamber pressure, which is absurd. That's for the kilopascal people. So how many PSI is that for the pounds per square inch, folks? That's, let me do some quick maths. That's 4,410 pounds per square inch chamber pressure. It's absurd. That is a ridiculous amount of power. And guess what? That thing has 33 of those. When this thing goes off, it is going to be the most powerful rocket ever flown by a factor of 2. How do they move the fuel? Fuel pumps. So Haji, I'll talk to you in car terms because I know you know this. What does a turbocharger do? Turbocharger on a car. It uses the exhaust gases, right? Uses the exhaust gases from the engine to spin a compressor. But turbos take time to spool, right? They take time to spool. Take your fuel pump on the electric fuel pump that you have on a car, right? You have the pump version and you have the electric. Take the electric motor off, take the compressor off of a turbo, and put the fuel pump and attach it to the turbine. That's how rockets deliver fuel. It is a jet engine attached to a fuel pump. A turbo pump. That's in the case of this rocket here. Some rockets some rockets are pressure fed. Some rockets just pick up on the residual pressure from the tanks and just use that to deliver the fuel. You can have pressure fed systems. Pressure fed systems work just fine. But this one, it has 2 turbo pumps. But what's even crazier is that once again, the Raptor engines atomize methane and liquid oxygen and then have a gas-gas system. They have gas flowing into the injector plate, which is absurd. That is so difficult to do. It's so difficult to get right. Think about it so Haji, think about it like this. You have your turbo pump things for your car, like I was talking about, right? You have your turbo pump thing. So you have your turbines picking up off the exhaust gases from an engine, right? And then attached to the front, you don't have a compressor, okay? Attached to the front of these things, you have fuel pumps, okay? Now, how Raptor works, this is where this gets weird. And talking about it in car analogy is going to get a little strange, but whatever. Say you have 2 weed whacker engines, okay? 2 weed whacker engines. And those weed whacker engines' exhaust goes in to your main engine. Okay? One weed whacker engine is basically flooding itself all the time with fuel. Not a lot, and it has a really small intake. So you have fuel-rich mixture going into your main engine. The other one, the other little weed whacker engine has a turbo, like a regular turbocharger on it. And that is, going through an intercooler and doing its thing, right? Going right into the motor. That's what Raptor's doing. There's 2 small rocket engines jet engines coming off the turbo pumps that actually are feeding the main rocket engine. That's part of the reason why it's so difficult. Like I said, a stage combustion cycle is like having 2 jet engines and their exhaust is going into a rocket engine and then exploding. Which is why when you have a stage combustion cycle, you have a pre-burner as opposed to an afterburner on a jet engine. Your main combustion is the afterburner with a rocket engine. Remember that. Hey, JWA, what's going on? Are the engines overpowered so they can run at, say, 80 to 90% instead of 100% to extend their lifetime? Yes. And having 33 for redundancy? Yes. Precisely, Midget. That's why Elon was incessant about 300 bar chamber pressure. So if you put 33 of these and they can operate max at 300 bar, if you're operating 33 engines at 150 bar chamber pressure, that's enough thrust to move Starship up into space and never stress the Raptor engines out, ever. Believe it or not, SpaceX did the exact same thing with Merlin engines. You ever notice how just Falcon 9's payload capacity over time just went up and went up and went up and went up, and then they just started landing boosters? They did the same thing with Merlin engines. Are the grid fins the same as on Falcon? They're the same in principle, Wishmaster. Those grid fins are about the size of a Falcon 9's diameter. Yeah. Or probably about 5 or 6 times the size of Falcon 9's grid fins. Hey, Alex. Wait, so in the main rocket there are 2 extra engines that pump. Do I understand that right? Yeah. Haji, this is why the car analogy didn't really line up. Because the turbo and the Weed Whacker engine in my analogy is built into one thing. Yeah, it's crazy, man. So I'll speak back in rocket terms here. So let's take Raptor's methane power pack. Okay, so at the top of the power pack, you have a rotating assembly, like a jet engine almost. At the top, you have your fluid impeller. Okay, your fluid impeller pulls methane from the tanks. Out of that fluid impeller, it splits, and some of it goes into the nozzle to keep the nozzle cool. Okay, the other split goes over to the LOX power pack, but ignore that for a second. After the liquid methane goes through the nozzle, it goes in, it's heated up now, it goes into a gas generator. Okay? The gas generator has a turbine wheel on it, and that turbine wheel is attached to the fluid impeller. So the staged methane, the heated up methane, goes in to a gas generator. They spray a little bit of LOX that's coming from the LOX fluid impeller, and they expand the methane, and that expanded methane turns a turbine, and that turns your fluid impeller. From there, and I say it goes up because believe it or not, the propellant goes into the impeller from the top, goes through the nozzle, and actually enters and flows over the turbine wheel backwards. So your liquid propellant's coming this way, and the gaseous methane is going this way. Yeah, weird, right? Because it's not a jet engine, it's a turbo pump. So you can do that. So the gas generator is actually on the bottom, and the turbine wheel is here. After that heated methane goes through the turbine wheel, it takes a right and goes into the main combustion chamber. And then the LOX side of things is literally the same thing. It's the same thing, only you're swapping liquid oxygen with fuel. And you get your heated up propellants, right? And it's important to mention, like I said, that the heated up methane and liquid oxygen going through the methane power pack is running very fuel rich. And then the preburner on the other side, on the LOX side of things, is running very lean. It's running very oxidizer rich, right? And those two, that fuel rich gas and that oxidizer rich gas, meet inside of the main combustion chamber. And that causes a very, very energetic and efficient explosion. Is there any of them that use gravity feeds? Clayton, all the tanks basically siphon fuel out via an accelerative force. You gotta remember, when the rocket's flying, if you're going up, that means you're negating gravity, but that doesn't mean you're not accelerating, right? Is that turbine part also the weak point of the rocket engine? You could say that. Yeah, here. I was trying to do this without the diagram, but yeah, Agulux has a good one here. See? Check that out. So you have your impeller up here, and there's your split, like I was saying, one of them goes over here to the locks impeller, and then from there you go through the preburner. It goes through the nozzle, comes out of the nozzle, and then your gas generator is right here. You have a tap off of liquid oxygen coming through there, so you have liquid oxygen and gaseous methane over here that are hitting into each other. And then you tell me from these temperatures and pressure readings if that's the hard point right there. From there, your staged propellant, because you sprayed some LOX into heated up methane, it'll explode. Yeah. It explodes, turns the turbine, which turns the impellers, and then it takes a right and goes into the main combustion chamber. Yeah, of course, Iceman, right? You're potentially super heavy. Your mom's super heavy. Got him. Crazy, right? On the LOX side of things, right, you have the LOX impeller here, and with this, it's more axial, right? So the LOX goes straight down. Some of it gets tapped off for the methane preburner, and then you have your autogenous pressurization split right there. On the methane side of this, the autogenous pressurization splits off of the stage cycle here. So what happens on the LOX side is that you have LOX going in, you get a slight tap off here, but see these kind of mushroom-shaped plenums right here? There's a gas generator in there. See, if you pay really close attention here and look, methane is being sprayed into this plenum right here, post-impeller. So you're getting a little bit of methane being sprayed in here, right? And that gets combusted with the LOX, but it's not enough methane to really blow up all the liquid oxygen. It just gets the LOX to spread out. That's all. You just get it to spread out, and you get the liquid oxygen to turn to gaseous oxygen. Hence the GOX, GO2, or gaseous oxygen pressure pipe. That's for the autogenous pressurization, which I was talking about earlier. From there, your extremely oxidizer-rich mixture goes through the turbine right there, and that turbine spins the impeller, and then the gaseous oxygen mixture from there gets thrown into Raptor's injector plate and mixes with the methane-rich mixture. And then that gets combusted in here. Once again, very energetic, very, very efficient way of doing this. Crazy, huh? It's an absurd design. Like, it seems kind of simple in principle, but the physics behind getting this to work, if you know a little bit about pressures and temperatures, you know about what, like 320 bar at 774 K is absurd. And it's 377 to 748 over here. It's about the same. And then you get 300 bar chamber pressure. You know, who knows what the temperature is in there. How to spread out the oxygen. Just exploded a little. Seriously. You explode it a little bit so it heats up. And you use up some of the oxygen. You spray it with methane. But the thing is, if you have a little bit of fuel and a lot of oxygen, only so much of that oxygen is going to combine with fuel and explode. The rest of the oxygen will be fine. It's kind of the reason why, like, gasoline vapors explode, right? Gasoline in liquid form doesn't explode. You have to get it to atomize. It atomizes via vapors, via pressure change. Weird, huh? Yeah, it's, dude, like I said, if you're looking at it and you're going, it does what? Yeah, I don't blame you. It's very strange. It's rocket science, like really difficult stuff. Could they throttle back with modular nozzles? Yeah, Clayton. Mm-hmm. Pretty absurd. 4,400 psi chamber pressure is nothing to scoff at. That's a lot of pressure. So you think there's a phase change for the methane while cooling the nozzle before entering the preburner? Yeah. Yeah, absolutely, dude. NSF is concluding their cast here. Can we get an instant replay of the static fire? Sure. Which part of the pre-burner valves, Haji? Pre-burner valves. Without the pre-burners, the engine doesn't work. I'm trying to find it. Any booms today? We got a little bit of action here. I'm trying to find it. Artemis Bullseye. Okay. Yep. Nope. One thing at a time, Thomas. Okay, here you go. Here's a replay.
Okay.
Okay. So
Okay.
FireX next.
All right. Headphone users.
All right, let's listen into the sound of these raptors.
Headphone users. Headphone users, last warning. You have 5 seconds to comply. That was nice. Okay, yeah, there you go. What else was in there? Somebody, Driados, you asked another question. How do you get the pressure to power the turbine rather than the pump turbine? You can't use a one-way valve as it will stay closed. How do you get that pressure to the power turbine rather than the pump turbine? So okay, little bit of nomenclature when it comes to rocket engines. If it's moving liquid, it's an impeller, okay? If it's moving gas, it's a turbine. If you're compressing gas, it's called the compressor. Really compressing liquid is called nothing, because even though liquids are semi-compressible, they're for the most part not. So there's no name for that. So what do you mean, Driados? What part are you getting confused with? I need a cigarette? It's pretty awesome. What part are you getting confused with here? Compressing liquid is called hydrolock. Yeah, it's called something. Smoking a pancake? It was at least 3 devious, but I have no idea. Nothing like sound of raptors roaring in the afternoon. Yep. Pipe in a crepe, bong in a blintz. It's pretty good, man. It's pretty sweet. There is no pleasing you, Pace. Walter Matthau. Sure, unfortunately for you, it's going to be bad news bears. Walter Matthau. So, just going back to this, you have an impeller right here, you have an impeller right there, you have a turbine right there, there's a turbine here, and there's an impeller right there. Yeah, Clayton, exactly. Put it in the skin box. Shave me from my shelf. $643 bar. Yep. May only use his movie references. Oh, yes, Guy. Actually, because this is February 2019, that's actually 330 bar now, which is absurd. It's just ridiculous. Is it hidden? Is it safe? Andriatos, if you're, where you're getting confused, I don't know, maybe you're typing it out, but yeah, I'll just keep going. But yeah, this is like, here's the thing. This is so fundamentally simple. There are other rocket engines that have more complicated systems than this. This doesn't look too bad, right? But where it lacks in diagram complexity, it makes up for in physical complexity. This is hard to do. This is very, very, very difficult. Yeah. Like I said, this is basically two jet engines shooting their exhaust into a rocket engine. That is not an easy thing to do. How do you do that without blowing a seal somewhere? Well, SpaceX, basically, a lot of testing is how they did that to get it to not blow the seal. Anyway. Yeah, they void Raptor engines on the test stand all the time. And you didn't even get into about how you start this thing. Yeah. Yeah. You need a very specific pipe to contain 700 plus bar of pressure. Yeah. Yeah. Mutter that. This should help explain why they have Elon has an incessant need to get rid of flanges. It's ridiculous, man, what this thing does. It's absurd. These numbers are ridiculous. If somebody showed me this diagram in like 2012, first of all, I probably wouldn't know what this means. But provided I did know what this meant, I'd be like, those numbers are impossible. There's no way you could do that. New Tory Bullseye. What is 700 bar? Like 8,000 PSI? Yeah, something like that, Katra. Yeah. There's nothing here at 700 bar. The highest I see is 643 and 633. Preburner is 564, which is just that is a lot. That is a lot. As the LOX booms, why does it boom down and doesn't go up? The impeller is forcing more liquid behind it. Gas is compressible, liquid isn't, so the gas gets forced down. Yep. Yeah, I know, Aquilus, yeah. Nuts, huh? Mr. Krabs do be feeling it now. Are you feeling it now, Mr. Krabs? Oh, that's nice. That's very nice. Very good. Anyway. You're making me want to play Kerbal. So that was the static fire. I'll play it one last time here, and then we'll get back into KSP. We got to work on our station core module today. I think I got a good idea for how the docking ports work, and if it doesn't work, we'll test it, and if it doesn't work, we'll figure out another way. Anyway, headphone users, again, headphone users, you have 5 seconds to comply before your eardrums get blown out. Nice. Very nice.
Discovery, go at throttle up.
Hotbox, 20-month resub. Also, rip new concrete. Louder, please. How many engine was this? It was at least 3. It looks like the new concrete may have been destroyed as well. This angle tells a completely different story. Yeah, headphone users again. That's just violent. You see the gate? The gate got blown open. No, meth lab there. Those engines on there have been fired multiple times. Dude. There's the poor cameraman. I don't think it's gonna happen, Ripper. Unfreaking believable, dude. That is an insane amount of power. Hang on, I gotta see where that video is coming from. That's coming from Epic Spaceflight. I'll link that up in chat. You always gotta give credit, man. Is that louder than Falcon Heavy? It's possible. Jeez. Ooh. Epic Spaceflight follows me. I'm going to follow Epic Spaceflight back. Damn, dude. I know it doesn't make sense, but if you replay the Starbase live feed for the test, it really does look to be a fireball on the upper left feed at 142.22. I'm pretty sure it's just a reflection, dude. There's no methane up there for it to do that, Havocs. I could say that with pretty high confidence. There's no methane up there to cause combustion. Did you see the grass fire in the NSF video? I did. The wiggle gif is funny. Those engines no longer exist. Here. How about this for a wiggly wiggly? How about... where are you? Ooh. How about that? You ever stared at it? Here, have all the wiggles? That's a lot of wiggles. Roll that beautiful gimbal footage. Yeah. USA, Envy, did they score again? Why no SLS GIF in flight control? That's not SLS up there? Oh man, they're in the 87th minute. Oh. Oh, we did get screwed by an offside. Oh no. No. No, 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 no. Was that offsides? Wait, okay, hold on. That's what you get for calling it soccer. Yeah, whatever. Sports sucks anyway, dude. I watched the Netherlands and Qatar go at each other. Everybody's just flopping around. Everybody goes ragdoll the second they freaking break a nail, dude. It's really, really annoying, and it's very distracting, and it takes away from the sport. And you guys should be ashamed for doing that. How does offsides work in this sport? I always get confused. I mean, the ball's up. Offsides is determined at the point of kick to the player. Oh, yeah, okay. Oh, dude, no, that's a stupid rule. It should have a blue line like hockey, man. Oh, that's so stupid. That's ridiculous, man. Oh. Yeah, dude, that's just barely offside. Oh, man. I hate this sport. Sport sucks. It doesn't. Soccer's all right, man. I just like giving you guys crap. That's a shame because it was a really nice goal. He faked the goalie out of his jockstrap. Dude, the goalie didn't even see it coming. Like, look at this. He doesn't even see it coming. Just whoop. He's like, no. That's just as bad as the flags that get called in football games these days. You will get no argument from me. Because, yeah. The Pats-Minnesota game, the Patriots-Vikings game was one of the worst officiated games in NFL existence. It's right up there with the Steelers-Patriots from a couple years ago. Literally the worst officiated game. I've never seen more missed calls. And you know what the messed up part is? The poorly officiated game against the Steelers from a couple years ago went in the Patriots' favor. But, you know, like, dude, I want my team to win and everything. That's fine. You know, like, oh, I want the Patriots to win every game. But, dude, there's got to be some continuity to calling penalties. It can't be not a penalty in one game and a penalty in another game. I can't stand that. Like, even if there is, even if you put it down to different refereeing crews, like, I know that happens in soccer too. It happens in soccer. In some games with certain refereeing crews, there's stuff that's a penalty and there's stuff isn't. There's stuff that isn't, and then that's different from another reffing crew. I want continuity from the reffing crews. So if the reffing crew called this a penalty in one game and they didn't call it a penalty in the other, that's bullcrap. Did you see the Abs no injury, no penalty call after a missed high stick? No, I don't contra, but it would probably make me really annoyed. Like the FIA imposing track limits. Bingo. You had your dynasty. Sit down for a decade or three. Yeah, here, let me just stop. Let's just stop winning so other teams can win. You know, because it's a round robin, right? You know, we have to be inclusive and let other teams win. We're talking about our football, Squall, not your football. Ugh. God, it made me sick to my stomach just saying that. Ugh. Disgusting. But yeah, either way, I don't know, man. Like going back to soccer, dude. The amount of flops just piss me off, dude. I can't deal with it. 6 minutes for Iran, or it's going to be Netherlands, USA in the 1/16 finals. I think you're right, dude. I think, dude, even if we win, trying to beat the Netherlands is going to be difficult. That's going to be tough. But don't count your chickens before you hatch. There's still time left. 35 million just for kicking a ball for 17 weeks. So what, Clayton? So what? If that's hey, price of labor is denoted from consumer, okay? It's denoted by the demand, all right? That's what we choose to value. Kicker's going to make a couple $1,000,000 per game. That's you vote with your wallet, dude. Just saying, happens in the video game industry all the time. Penalties should at least be reviewed in the booth to kick out the worst ones. It's such an obvious thing to implement. Yeah, Wisp, here's the thing, dude. The booth actually overturned the ref's call in the Patriots game, which was the right call. I don't think so, Z-Gogs. I don't think so. Like, as much as I want my team to win, I don't think even if we do beat Iran, that playing against the Netherlands is gonna suck. Anyway. All right, let's jump back into KSP.